Welcome to Build Up, the European Commission's portal for energy efficiency and renewable energy in buildings. Directly stemming from the Energy Performance of Buildings Directive, Build Up is the meeting place for everyone involved in making the European building and construction sector more energy efficient. Every month we focus on a topic that is key to making Europe's buildings as energy efficient as possible. Exploring that, you can find the latest content such as expert talks, webinars, case studies and more. From architects and engineers to academics and policy makers, we've got you covered. Build Up brings together thousands of registered members to reap the benefit of Europe's collective intelligence on all aspects of energy efficiency and renewable energy in buildings. The Build Up portal benefits from the expertise of our ambassadors. Drawn from industry and academia, the ambassadors bridge the gap between EU and national level and help shape our editorial content. Want to promote your work? Build Up disseminates your research, projects and events through a variety of channels. Become a member to exchange knowledge with your peers. You can disseminate tools and resources, share good practices, and consult open source publications. Join the discussion on social media and become part of the Build Up community, or subscribe to our newsletter to receive the latest news. However you participate, the Build Up portal is here to inspire, inform and connect. Build Up, the European portal for energy efficiency and renewable energy in buildings. Join the community for opportunities and updates.
Good morning and welcome to today's webinar. My name is Arantzazu Galán González and I'm a member of the Build Up editorial team. It is a pleasure for Build Up to host today's webinar and workshop event entitled Driving Sustainable Digital Workflows, Exploring Open BIM, Data Standards and Energy Efficiency Innovations, brought to you by the Austrian Institute of Technology, AIT, and Build Up. This online workshop will shed light on some key technologies needed for digital planning workflows. Before we begin, we invite and encourage the audience to send us their questions or comments to the speakers throughout the session. To do so, please use the GoToWebinar question function. These questions or comments will be addressed during the Q&A session at the end of the presentation. The agenda for today's webinar will be composed as following. Gerard Zucker, Senior Scientist at the Austrian Institute of Technology and Operating Agent of Annex 91, will make the introduction to the topic. Andre Littner, Senior Consultant at eClass, will explain the activities of the data standard towards BIM and environmental footprint. Mirbek Bekvoliev, Technical Project Manager at Building Smart, will talk about the recent developments of the Open BIM workflow as IDS and BSDD to IFC 4.3 regarding BIM and BEM. And finally, we will have Gerard Zucker back to explain the results from IEA EBC Annex 91 Open BIM for Energy Efficiency Buildings. Before concluding, we will have some time at the end for Q&A from the public, moderated by Build Up. And now, without further hesitation, we will move directly to the first speaker. Gerard, the floor is yours.
Thank you very much, Arantza, for the kind introduction. I would like to welcome everybody to this webinar, which was kindly organized by Build Up. The initiative comes from the Annex 91, which is from the International Energy Agency. And Annex is a networking international network program. And our Annex, which is now the framework for this webinar today, is Open BIM for energy efficient buildings. So you will hear about related technologies, ongoing developments in Open BIM, and also about the content of the Annex. And with the short introduction, I would pass on the floor to Andre.
Thank you, Gerhard, for your introduction. Hello to everybody from my side. My name is Andre Lindner. I'm from the eClass Association, and I have the possibility and I want to present you something about our activities of the data standard eClass and in the direction to BIM and explain something about the environmental footprint and other themes what we have in the standard. To see some facts about E-class, oh, sorry, that was one click too much. Now we have the slide here. Maybe for you it's interesting how many users are behind the E-class standard. So we have something around 4,000 users. That means companies and organizations which use E-class worldwide. The standard is available in 31 different human languages. We have 46,000 classification classes for classifying materials, articles, services, and everything like this. For describing, we have 28,000 properties, and it's very important that we are an international standard. We have 7 international offices worldwide. We work together with 80 cooperation partners in different areas, and that's only to know a little bit more about E-class. Sorry. Okay. The standard is based on a data model of ISO IEC. The idea is that E-class as a kind of data standard, as a dictionary. In the end, we work with catalogs which are based on XML or something like this. The idea is that the data are machine interpretable in the end. And you see, E-class is not only for the construction area, it's a cross-sectoral standard for a lot of branches, a lot of sectors. E-class wants to be compatible to other data standards. ETIM or the applier, which is a European standard for the white goods, and we work together with some other standards. And in the direction of building smart, I will show you in the next slides the idea between this. So our main task in the end is that E-class wants to support the data supply chain. We know that companies needs a lot of data to produce something. And now, today, we speak about buildings. We want to construct a building. We need a lot of material, components, services in the end. We know that this whole articles, materials, and services are not only from one company. We work together with a lot of companies, which delivers, which are suppliers for this, and which are engineers for this. And so we have often the situation to build up something like a building or a machine. We have a dialogue with other companies, and we often have the situation we want to purchase something, and we don't want to have only the article or the material in the end. We need the data too. Then we have a chance to use this data from our supplier in our processes, which are behind it. And we need this for the engineering, for logistics production. We always have this, and the after sales in the building area means facility management or something like this. And that means in the end, the customer which wants to buy a building or a machine or whatever is not only interested in the building or the machine. The customer is interested in getting very good data with this product in the end to work with this data in his in the whole life of the building too. That means we need uh, always to get product data and standard that means standardized product data, because that's the only way to bring data together without complications, and then we can add more and more data, and in the end we have a package of good building which has good data too. That's the idea. And if we look into the standard, E-class standard, then we see the first level. When you go into the standard, then you see we have a lot of so-called segments, which are themes or segment or sectors. And I made a box around segments which has something to do with the construction industry or with the BIM, with the buildings. So you see it, maintenance could be a theme. The construction technology is the central theme. But always we speak about fixing elements like screws or something what we need to build up the building. We need general services. Here you find the facility management and something like this. Very important, the electric engineering, automation, everything what you need for your building, which is engineering. You see it here. These are important segments, and I brought an example to you to explain E-class. It's the hinged door. You find the hinged door here in this area in the construction technology. Then we have the door, gate, window. We have the door, and then we have the hinged door. And this is the only the first step for the supplier to say, my article, what I want to bring into your building is the hinged door is here, this article, and I can describe in the next step this hinged door with properties. But here is another thing, you have a definition, what is meant by hinged door, because it's very important that everybody who works with this standard know what is meant by this word hinged door, and for this you have the definition. The IRDI, what we see here, is our way to make the product data to a machine readable product data. So in the end, everything what you describe by E-class will have a package of IRDIs. IRDI for the classification class, what we see here. And then in the next step, when we go to the description of such article, then we have the possibility to use properties which are behind this class for the hinged door. And you see there are a lot of possible technical descriptions possible by using this standardized properties. And in my example, to understand a little bit more about the properties, we see maybe the next, there is a animated, no, there was a animation behind it. It's not possible. Okay. Okay. Okay, here we see it. My example of a property is the handle type. And you see the handle type as a property has a so-called IRDI2. That means we always work with this machine-readable IRDIs, and we have a definition what is meant by this handle type. Then in the next step, you have a value list for the handle type, and then you can say, okay, for this door, my handle type is a knob or another kind of handle type. So it's only an example to describe the articles completely, and I must do it a little bit fast, but I think if you have questions in the end, it's possible to make a contact, and we can do it maybe deeper in another possibility. Here you see the aspect environmental footprint. It was in the list what I shown you before, and it's a very special kind of a block in our properties, because we know the environmental footprint is very complicated. It's a very complicated thing. It's much more than only one property. So that means we have an own aspect for this, which is called environmental footprint. And then you see in this aspect, we have some different property blocks. There are some blocks. Here's the block for the climate change of product carbon footprint. So it's very important. And we see there are some different methods, calculation methods, standards to describe the calculation methods are possible. And you see there are more and more possibilities to describe the footprint, not only the carbon footprint. You see here there are the toxicity, there are the eutrophication for terrestrial, aqua, fresh water, and something like this. The water use, the land use, everything are very important things of the Green Deal, which we need to describe. And if we go here in the ozone depletion, you see it's a lot behind it, and there are always from the standards which are available for this kind of theme, you find here the value lists of it. And so it's possible to bring these very complicated information into a machine readable form in the end. And so it's possible to bring it in the data supply chain, so that you can bring from the supplier the data in your machine, in your building, whatever you want to build up. And then in the end, you have a chance to say something about the carbon footprint of the whole building. When you get the information of a lot of components, a lot of spare parts, articles, materials from the supplier, only then you have the chance to say in the end what is the footprint of the whole building. So, and for you here in this meeting, I think it's important to see what are the strategies and concepts of the so-called E-class cross expert group, BIM. So we have a cross expert group for the theme of BIM, and you see there are some companies, Strabag, Zyplin, Siemens, Schneider Electric, Phoenix Contact. These are partners here in this special cross expert group what we have in direction of BIM. And you see we have some themes. We work in corporations for this theme. We have some other points of context. You see here are standards, important standards which are connected to the E-class theme and to the BIM theme, and we want to bring it together. Then we have a very important thing, and I think we will hear in the next time something about the BSDD. We want to bring E-class as a domain into the BSDD, but I think I must be a little bit faster now. Sorry for this. And I go to the next slide. So we know that we have some differences between the data model of E-class and BSDD. So you see here, E-class works with the ISO 13584. And the BSDD is based on the ISO 23386. So we have our themes, and we work for this, that we find the translation between the data structures. That's the basis for implementing parts of E-class into the BSDD in the end. So then only that you have heard about this, E-class is the semantic of the asset administration shell, the AAS, which is very important in the digital twin from the machine sector, from the mechanical, electrical engineering. So what we have seen, the properties and everything what we have in E-class are a base for some submodels in the AAS. And this is a base for the DPP in our point of view, because we say to describe a digital product passport in the end, you can use the AAS, and in the AAS you have the so-called digital nameplate as a submodel, the technical data, and the environmental footprint as submodels, and the properties and the kind of description comes from the E-class. And you find in the specifications of the IDTA, which is the organization to produce the AAS, you find the E-class IRDIs in it. So that means that's the connection between E-class over the AAS and the DPP. So that's what I only bring as a point to you. And the idea behind it is to have a solution for the EU strategic program Green Deal. You see what is the themes today, and I want to do it only very fast because we will hear some other things in the end. Sorry, there's no possibility to come to the next slide. Okay, because that was my last slide. Okay, I hope I'm fast enough, and I think we will have the possibility to speak about some questions in the end of this meeting. And now I can give to you, Mirbek. I hope I stole not too much minutes from you.
Everything fine. Thank you. It was really interesting. Hello, everyone. Not to lose time, I will directly start. Thank you, Gerhard. Thank you, Build Up team, for great introduction and organization. On behalf of Building Smart Germany and on behalf of working group PSI BIM, I'm glad to join this event. Before I will start, I will go through some details. If you still have questions, you always can reach later on, and plus all the links will be shared. Plus you can simply rely on that the presentation will be shared as well. All right. I'm technical manager of Building Smart, and of course helping our working groups and projects with technical questions and projects. Let's simply dive in. All right. As you can see on my screen, there is an IDM or technical report that was published some years ago. It's called Building Energy Modeling with the help of BIM, let's say. Most important that it's open BIM. Of course, it's an open BIM workflow. All standards and services for Building Smart are really in focus, and we try to work on this document among other associations together, hand in hand. We try to collaborate with all organizations involved in the sustainability and energy efficiency plus certifications. So we had the chance to identify some workflow. We had a chance to optimize them, and as a result, we had an exchange models. All that exchange models later on, together with Jeff Roulet and Paul Woodard, we had the chance to create an IDS. What's the IDS? I will explain shortly. And you will find it as well later on our use case management as a published document. This document you also can call under the Building Smart International Repository, so you will find it there under the link. We try to test that document, I mean that IDS, which is exchange requirements that you can see defined in machine and human readable way. So we had a let's say a theater play in first try in Valencia. We had a group of experts who played their own role, starting from mm, building owner until sustainability consultants and architects, and everyone had a chance to test their part. So we had a role play game, I would call it, and you will find the recording for that. Second trial of ideas BIM on BAM was in Marrakesh as a BSI summit. That was a second use case where we had a existing building. So ideas is for everything. I would call, you can start from new buildings and end up with retrofitting as well. As you can see, all that standards and services belong each other, or let's say interconnected. They support each other, enhance workflow. As you can see, we have a buildings, assets, or facilities that could be described through IFC models. You have a chance to capture information, document, share, communicate, and share tasks and issues through PCF. You have, like already mentioned previously, like E-class classifications, A-team, and other classification like IFC as well. Within BSTD, Building Smart Data Dictionary, and now you have machine readable and human readable standard IDS. That all interconnected. I'm a European Climate Pact ambassador, and glad to show you that we have also a chance to address that topics with the help of OpenBIM. And as you know, 40% of energy consumption goes to the built industry, and more, like big majority of all that energy goes to the existing built stock. So you have leaky buildings, less insulations, or no insulation at all, and so you have to address all that, and especially existing buildings. For that reason, we addressed the second case in Marrakesh for existing building, just to show what challenges we may face. And this challenge, one of them, is capturing of reality. As you know, there are many options that you can get. You just can try to scan the building, go through with thermal imaging to see what other issues like thermal bridges, air leakages with the help of blower door tests, and run energy simulation. But to run energy simulation, and we are working now towards that, you need to have a proper model, right? So you have to capture all that information. Oh, what kind of information you may capture? Potential leakages, potential thermal bridges, moisture content, structural damages, humidity, and so on. So mold, like harmful content within the building materials. So as you can see, all that could be found, but we need to capture them, we need to document, and there is a use case for that. We published with Geoffrey and Geoffrey Wallet and Gianluca Genoa in the past together, and there is a use case, as you can see. I will skip at this part, you will get a link. And now an example that we brought from Marrakesh as an example that we run a role play game. As you can see, there's an existing building we're currently sitting in. As you can see, we can capture that information. Well, the reality is that you have old, outdated building. I will not call them models, blueprints, if you have at all, and they are not capturing reality, right? You find completely different reality on site. So you have to capture them. You have to document all the stuff. You can document the physical stuff as well, like as you can see, building issues or the building envelope issues and so on. And we do that with BCF as well as a BIM collaboration format. If you're not familiar, please check it. As you can see, there is a part of the BIM and BAM project. We had the optimization of workflows, and we start at the very beginning capturing that information, and that goes deeper. And there is an open BIM workflow building smart implementation that starts with capturing information through building owners via IDS. And it's not only building owners, sustainability consultants, structural engineer may have specific requirements. I, as a lighting designer, I may have a specific requirement. So I can capture that in IDS. That's what we worked on. So BIM and BAM IDS is here as a draft and is currently on the third test. So we can maybe publish someone soon, which created that. As you can see, you go through this loop and you create something. As a test, we said, okay, I have a building. I want to have a new ceiling, and I want to preserve the old panels. I want to preserve in structural members like timber, reclaim them. I want to use non-degradable or like non-degradable materials. I want to use VOC-free content materials. I want to use, as you can see here, you can describe everything with the help of ideas. Almost everything. And as you can see, the IDS is in a human version, left is a simplified way, and you will find it in a machine readable. We provide that to an architect, let's say to an architect or designer or someone who is modeling that building later on, and we capture information through IFC schema. We can use 2x3 traditional way, IFC 4 more advanced, and IFC 4.3, which is more extended to IF infrastructure. And plus building. So there are some minor differences between IFC 4 4.3 in regard of building. So, but still, IFC 4.3 is more advanced and they have more chances to capture better information. As you can see, we try to capture information, pre-retrofit case and post-retrofit case. It means we also want to have some specific properties that we want to capture and and give information to workers, because we have potential hazardous materials, asbestos. We can face mold and so on. So you have to know that information in advance, and it should be in a pre-retrofit building, and you have to get that information. And we do it through BSTD. And an example, as you can see, there is a dictionary called decommission and reuse. You will find it there, and there is a hazardous materials classified. You can add them into your building parts components. That's how it looks like. IDS, human and versus machine readable. Just go through it. You can even forbid some kind of information like proxies. So it's very common that if you want to run a simulation, you will face low quality models that potentially have IFC building element proxies. You cannot start with them because some of them are not classified, and you will not be able to import them. My simulation tool knows only IFC wall, let's say IFC window, IFC door, and so on. You need to classify them, and that's why you can forbid and tell model checker with the help of IDS, I'm importing that, and I can check, run the quality control of the building if all classes, all components are meeting my requirements. Not only requirements of IFC, but in general, my client requirements, my sustainability requirements, and so on. And I can prepare the building for that. As you can see, the previous case during the construction, what do we have in reality behind the ceiling? And we had to capture that with the help of BitCF. We captured that, and as you can see, we have some area to capture with IFC spatial zone. We store it in specific spaces, and we prepared the simulations, run that simulations, and the result also captured the end result within the building. And now comes to BIM and BAM. Building energy modeling. So we need some information like U values, or like lambda values in that case of materials, and you need to have information on building envelope, let's say doors and windows, and I have the specific information. Here's just an example. I want to have all components have a lambda value, and those thermal values I can put into my IDS as a specific. I don't have to create custom property. I took it from BSTD as a, sorry, in the German version, he has a WMF but it's a thermal conductivity, and I put it into BSTD and should be better than 0.75. What does it mean? I model that. I use also APIs through BSTD. So it's like a single source of truth. All of information It ends up in my model. As you can see, here's a model checker, and you can see I have the thermal conductivity and 0.75. It meets my requirement. I can also prove that this meets my requirements through IDS. IDS validates the model against the requirements. For the same thing, just in a small use case, daylighting. Daylighting is very important for energy efficiency. Make a bigger window on the south facade. Try also to keep up on try to keep or avoid overheating. So you need to plan that, and you run simulation. You will see the differences. And how will you run simulation? There are some protocols, like just an example, and we created one use case, like daylight, open beam for daylighting analysis, and in respect for energy efficiency. That was a second or third use case that currently available on UCM. What is the covered? I will simply skip. You can just go into use case. You will find all that. This is not theory, but there's some information, and also IDS available. You can start using it. Of course, it should be updated as well. It should adapt it to your project. You cannot simply take one idea. You need to adapt to your specific project. You can extend it. It's open standard after all. So as you can see, check inputs and outputs. So the way you do it, and that's how it looks like. I run simulation. I put into that IFC model into my simulation model. I need to have IFC to X-ray schema because of some other reasons. I had to have all specific parameters and properties, classes, really simple ones, so that my model could be imported, and that worked well. As you can see, I had the chance to simulate and report it back with the help of BCF, and there are some steps. I will skip this part. You can get it later on and check. I can run simulations in between. I did it for LCA calculations, for daylight analysis, for energy efficiency, energy demand, and so on. And as you can see, there are two cases. You can run IDS for pre-retrofit, so you prepare that, and for post-ret. Let's say pre-retrofit, you had a U value of 0.03040, and post-retrofit, the ceiling or the roof should be the U value of 0.03, just an example. Oh, sorry, for lambda values. But then you have to put into your model in that case. So I can, as a building owner, I can test that and validate, as that's what open standards is for. I run my simulation. As you can see, LCA calculation, energy demand calculations. I can put through plugins. I run simulation based also on IFC model. And there is also some publication, as a BSI Sustainability Strategic Group published recently, a use case on UCM. There are 3 ideas that you can also try to improve those. Plus, there is a dictionary called LCA properties. You can put them, so you don't have to create your own properties in in your IFC model. You put them, you take them, and as just an example, I want to have these requirements and this property in our model. As a result, I use APIs. As you can see in the Revit, I had an API. We put that property with its value, and now we can see in the Revit directly with the value through the simulation coming in, and we export IFC model after all with all that standardized properties. I didn't spend any time for creating custom properties, but used existing one, standardized one through BSTD. So as you can see, this could be not only applicable or not only for facility, it can be applicable for heat pumps, as here an assembly, let's say the unitary equipment, and there's a heat pump. Also mapped with VDI 3805. We had a chance to map it with other dictionaries as well with the help of BSTD. And we at the end validated it. As all validation, as you can see, those triangles with warnings. You can see, you can apply changes, you can improve the building. How it works, IDS, check it, this link, you will find it out, IDS and Building Smart, you will find it in the internet. Let me skip that part. Now, this is important. standard as well, BCF. It's not just for clash detection like classical or for planning. It's also operation, for documentation, for retrofitting. Please keep in mind. As an example, I run my building energy simulation. I don't have to put that back into my building model. I can simply send, based on the model, I can send this BCF and it will be all documented. Is this still open? Is this topic open? Yes or not? So we can simply track back. If you want to experience more, please join our events. Next one is actually in Singapore, but then in Europe we'll be hosting a summit, Building Smart International Summit in Berlin. You're all welcome to join. But if you have any other questions, feel free to find me on LinkedIn or drop me a mail. I will be happy to help you and give you some more insights. I hope that was clear, and if you have some questions, feel free to text me in chat. So now I will give stage to Gerhard. Thank you.
Yes, thank you very much. Thanks for the deep insights, Mirbek. That was really what we are about in the Annex project as well. I'm taking a bit of a step back. We heard a lot about BIM now, BIM technology, already a deep dive. Looking at what is out there, we see we have different levels of information exchange. So we have this unstructured approach where PDFs are passed, which always requires one human to pass a document to another human. We have some semi-structured data, table-based, which can be computer read, but still need a human to interpret. And what we've seen now, what Mirbek has shown us, is what we really want to implement on a broad spectrum, model-based communication between computers, that there's no need for any human interaction to exchange data. So also what we've seen with Andre in the E-class, that you really can exchange data between companies. There's a lot available already, as we have seen, but there's also still work to be done. I think very quickly, if you missed that part, BIM is both a process and the technology. So we're looking at geometry data, we're looking at alphanumeric data for our products or for our components. We have authoring tools on the one side, we have other applications on the other side. One, for example, being cost calculation tools that want to work with BIM data or thermal simulation tools and so on. And this is what we're basically dealing with in this open BIM for energy efficient buildings annex, in this network project that's organizing this webinar today together with BuildUp. We want to have really a broad acceptance of these BIM processes and data models. We want to advance the interoperability based on IFC, as we've seen today. IFC is the de facto open BIM standard for exchange of construction data, and it also goes further into streets and bridges and tunnels and so on. We are focusing on the construction of buildings, but this is what we want to do. And we're also going with a strong focus onto building energy performance in this regard, because this is really, I would say, the holy grail of interoperability. If you manage to send an architectural model to some program and it's capable of doing a simulation with this, then we have really achieved a lot, and a lot of work has been put into that already. Who is we? As I've said, we're an international networking project, IEA EBC, Annex 91, and you see we are 21 collaborators in 10 countries. And we have additional parties that are informed about our progress, what we are doing, and one day may also become collaborators. And at the end, I will say a few words about how you could also possibly become a collaborator. This is just the team of leaders, of subtask leaders. As you see, we have Germany, RWTH here, Lund from Sweden, KTH from Sweden. We have Cardiff University here, and from Austria we have Digital Findet Stadt, and myself from AIT. So this is part of the team. And what we've done in the beginning, because we have so many topics, we were collecting all these activities. So this includes all the research projects that we have been doing, all the thesis reports, etc. and we aligned them. You see a list, but this is of course too much to process through. That's what we've done, but we aligned them in phases, saying what is relevant for design phase, what is relevant for operation and control, and what is relevant for refurbishment. And then we also made a horizontal division into what is relevant for the BIM processes, what is more tools and algorithms, and data and ontologies. And then we put in our topics there. So now we have a possibility to really get the right people into the room and really work on topics that are aligned here. So this is just the structure, how it works. And I would also now want to look what we are doing on IDS side. So IDS, as Mirbeck explained before, is a definition of the information structure in a building model. And we are working on collecting use cases, case studies, so to say, and define such IDS specifications to see if they can really deliver everything that we want. This IDS has different advantages. For once, it defines what you expect in a building model. So if you say there is a slab and it's made of concrete, then you expect all the properties relevant for concrete to be present in this model. You can define this. That's why it's called a specification, and you can also check the model. So this is a part of model checking. If you have the specification, you could do an automated model checking, not only once in your model, but really on a regular basis. This is, if you remember what I've said, we want computer-to-computer interaction. We want continuous automated data checking. Only then can we guarantee that the quality is really sufficient and that all the information is present that we need. And this is one of the collection of case studies that we're doing here. Sorry, and learning also how to improve IDS, and all this will go into a peer-reviewed journal in the end. Another completely different view on buildings and on data models is building as a service, an initiative by RWTH Aachen and Cardiff University, where we say, what if a building provides services, like in the facility management approach, we have all kinds of appliances, heating, ventilation, air conditioning, domestic hot water, etc., etc. But looking at it from the perspective of who owns the data and what happens with the data, who has the ownership, and how can you process this data, we're looking at it from a service side. So whom do I need to talk to if I want to access data? What does this imply? How can I make all the processes that we have now in construction better, improve them? So it's not a technical interoperability, it's really a service perspective of the collaboration between the different parties. This also will go into a paper, so this will also be published. You see a paper here already. This will be also the link made available, and there's also work going on there. And another different view on this. It's not all technical that we're doing. It's the question of looking at the uncertainties in the design process in terms of information exchange. I'm sorry, the font is a bit small here maybe, but I'll walk you through. The idea is this is the first basically stage, the concept design, where the question is, if you have data that you need, what uncertainties do you have in those data? So you may have some some constraints that say you get data about the window, but after the planning permission application, the window dimensions are fixed, but the glazing is not fixed yet. So you have a possibility of changing one part of your window, one set of properties from your window, but not another set of properties. And what does that imply? So if you use better glass, the thermal abilities of your building improve. And if you use only the glass that is allowed, the maximum thermal conductance, then you get another behavior of your model. And this is questions that we try to address here by building up a matrix that shows what impact we have from the different sides of data that we are providing. So it goes a bit on top of the data model, looking at this. And of course, more hands-on, we're looking into use cases for BIM. We're collecting use cases. We have models acquired here where we're looking at how can we get to this BIM to BEM conversion, like we've seen before, the building performance simulation or the building energy modeling. How good does that work? What do existing tools provide? What does it need? Does it need better interfaces? How can we adapt tools to IFC4, the latest version of the Open BIM standard? There's a lot of operational things that need to be resolved before we can actually have a successful, seamless interoperability for thermal simulation. This is one group that we're working on here, but there's more, of course. And another perspective, this is now going a bit into the technical details of what BIM actually means. BIM for building services, and by building services, this means mechanical engineering, plumbing, so heating, ventilation, air conditioning, and all the rest of it. We have some definitions, they're available, but since they are the newest addendum to the IFC standard, there's still a lot of work to be done, especially because this building services has a different perspective. If you think of a heating system, then you have the outlets, you have the ducts, you have the heat register, you have the energy provisioning. So this is a whole system that cooperates together to give you comfort in your room. So you need to have a system view on that. You not only need the construction properties, the ducts and the outlets and the volume air controllers, but you also need to describe the function of the system. Where does it provide the heat to, what kind of heat, and so on. And you need some other information. Are we talking about air, water? Which medium is it that you transport? So you have very different views on this, and an additional layer of the whole building automation perspective. So communication, which data points do you need? What control cycles do you have in there? And all of this shall also go into BIM so that we can work on the same model. I put here a very simple example of an office building that we have here. One room here, and you need this information about this room in your model. So you need about information about what temperature do you want, what CO2, what humidity set point do you want, how many people in this office will be. And if you have all this information available in an open BIM model, then you have a possibility to go further with an automatic processing of this and doing a building energy performance. Now, if some of these topics are interesting for you, and if you're an academic institution, then this might be interesting for you to join the annex. As I've said, we're within the program of the International Energy Agency, Energy in Buildings and Communities, EPC. And we'd love to get to know you if you have research going on. So if you have ongoing projects, PhD students, etc. It goes on a country level, so your country needs to participate in this. But as you've seen, we have a lot of countries already, so there's a chance that your country is already part of this annex. If not, there's also ways to do that. We're still going for another 2 years. So this is a possibility. If you're interested, please contact me, Gerhard here, the operating agent of Annex 91, and then we can sort that out. We still need BIM competencies. We still need research that we would like to look into. So I would be happy to get in touch with you. Thank you very much.
Thank you very much, Gerhard. Thank you very much to all of you. Such an insightful and full of information webinar. Thank you so much. We have the audience. Now we have already some questions, but you can continue to send it to us. So let's go for one directly for Mirbek. What is your simulation software and how detailed the BEM is? BEM, one zone per building?
I have heard the first part, which is simulation software. There is not only one simulation software, there are combination software. The use cases are different, and you choose one for a specific one, and there are all have their own advantages. Okay, it's not an advantage. Please don't regard it as advertisement. the one is really tricky, but it's really reliable. I'm using PHP. It has a really long workflow. PHP is actually Excel based, actually, but it has a plugin that enables IFC import, but it goes through SketchUp first. You import IFC, you export then into platform. It's got um, the got through SketchUp, you import into the platform, and then with the help of IFC. So that was so it's a passive house planning package. That's a calculation tool. That's that you calculate the whole and not whole energy, the whole energy demand, but as a what do you call it, building envelope based.
Mhm.
If you use zones, then of course Energy Plus. Plus you have for Energy Plus you have two. In the past I used Cyberterm. They have really good IFC importer. Yeah, you can import IFC and you can run simulations directly. Of course, if it's good prepared IFC model, then with a second level space boundaries, and it will work perfectly. So this is the biggest challenge. You need to express all that information, all requirements for someone who is sending you architectural model to do run simulations. For daylight simulations, it's easy. It's one software that's open source available. I'm not open source; it's free. It's available. It's a Dialux. You can run daylight and even lighting simulation model. You can have a chance to import IFC models as well, which is really advantage for everyone if you have. And in the past I also used design build plus energy plus and one ESV virtual environment. All supports IFC. Energy plus was tricky. You need to have some plugins additional, and there are some extensions that you can find on GitHub and so on. Yeah, I think it was first question I answered. Second, what I didn't get the second question part.
You have answered it because they were asking if you do it because one zone per building, but you have answered that is per building,
Yeah,
and
of course you
so you
need,
make
first
it
of
you make it
all, yeah,
inclusive.
spatial. You need to have depending on the software or depending on the purpose or goal of the simulation. Um, you need to have IFC spaces, yeah, with rooms. Let's say call them rooms in Revit and so on. But you need to export the spaces. So IFC space plus a second level space boundaries. That's most important. If you know them, you will be able to import in most of the energy simulation tools. By the way, in the BIM and BAM technical report or IDM technical, we did some kind of analysis. So if you go through links, you will find them some examples that supports IFC.
Thank you very much, Mirbek.
No.
We have put all your links during your presentation so they can go through them. Perfect. Let's go to Andre. Andre have talked about E-class as the data standard. Why E-class speaks about a machine readable standard and how does it work?
Thank you for this question. So the idea behind it is that we know that big companies work international. So BASF or Strabag or in each sectors we have very big companies, and it's mostly in the situation that um, they work all over the world, and maybe there is the data specialist who wants to describe products, articles, materials are sitting in China. And so it must be possible that there is a way that this man or woman can describe it in his human language, in the Chinese language, and then you find for each structure element the so-called IRDI. That's the special identifier, what I have shown. And that means it's equal in which human language you find the the URDI. In the end, you have the possibility to switch it into the machine-readable URDI way. Like Gerhard has shown, it's the idea to have in the end a possibility to bring it in an XML file or in a special specified file in which is completely machine readable, and then you have the situation that the machine knows the standard, knows the URDIs behind it, and so it's very easy to bring the right information, the right data to the right point in your software and to collect it, to bring it together. And you have, in the end, if you get this kind of information from your supplier before, then you have the data chain, and in the end, you have a completely packet of good data, readable, machine readable. That's the idea behind it.
Thank you very much, Andre. A little bit for all of you, but especially for Gerhard, as he make a broader presentation of the project. There is a question that is always in the air for our audience, is that we have been talking about BIM for many years now, and it's a no-brainer that is the way to go, no? Because we can really condense a lot of information in that methodology. But why is not yet a complete deployment of BIM in our construction sector, for example?
That's a very good question. Thank you for that, because this discussion comes up a lot of time. There's even talks that BIM has failed and all the rest of it. I do not think so. I think we have a huge challenge that we need to solve. If you think of, as an analogy, the internet that we're so used to now, it was built up on so many different layers of communication standards. TCP, IP, UDP, SNMP, I don't know, there's an abundance of standards, and they all define everything down to the bit how you communicate, and they do functional descriptions and a lot of different things, that this really works seamlessly from a high performance computing cluster down to a mobile phone. All this uses the same technology. And this is what we still have to implement in the construction sector, because the construction sector does not have digitalization in its DNA. We're used to doing things, constructing things, and if it's on a paper, then it's fine. So we have a certain level of interoperability now, but we need a much better definition of this, much stricter. So if you really want to have machine-to-machine communication, you need a specification from the lowest bit, so to say, all the way up to the application and beyond. And this is what we're trying. As you've seen with E-Class, this is a very good, very precise standard that defines very well by identifier what we're talking about. We have the same concept, global unique ID, in IFC as well, that identifies what we're talking about across language barriers. And we need to have this for all the components and also for the systems in the building, and of course for all the different disciplines that work on there, because we always have a multi stakeholder problem in BIM. So it is complex, and we have to keep working on that. So BIM works on certain levels already. It's already well established. You can exchange data, but there's still work to be done.
Yeah, you have a lot of defenders among the audience, that they are saying not only in Europe but all around the world what makes a common language. It's absolutely true, but it's true that some countries, for example, they are not so fully working with BIM. What is a pity, because it's really complete. We go back to Mirbek. Mirbek, it's a very practical question. Should we create our own information delivery specifications, or could we use any template?
Shall we use our own ideas,
Yes.
or should
we
we
can
create
use
completely from zero, you mean, or from
Yeah, I believe.
Okay, well, you can do that. there are some links you have seen. You can also, since it's open standard, you can use some templates. You find it also in use case management. There are some use cases that provide ideas as an example. You need, of course, to adapt them. So you need to change an address maybe of the facility or building. You need to change the values, specific space names as well. Maybe you may have specific, let's say, additional property sets with properties and there are specific values. So you can add in on top, since it's open standard, you can import into any other editing tool. IDS editing tool, you import that, you extend it with specific classifications, classes, types, properties, values, and so on, instructions. So you can add them and apply to your project. So it should work. Anyway, it works.
Thank you very much. Andre, one question because you you have to go very quickly in your presentation, and you leave a little bit in there the link of E-Class with the Green Deal. That is very interesting for all of us, even if we are not so technical as you are. Can you go further, a little bit further on how E-Class will link to Green Deal targets?
Yeah, sorry, that was very short. The idea is, so the Green Deal brings us to the situation that we need the DPP, the Digital Product Passport, in the end. That it started with batteries. So that's not a building theme in the first idea, but batteries are always in the world. We know it. This is the starting point, and E-Class can describe the batteries via the properties, and we know that the DPP comes to the textile, comes to other points, and in the end we will have it in the building sector and the construction sector too. Because we need everything in the building. We need textiles too. We have a lot of textiles. We have a lot of things maybe which has batteries. So in the end, the kind of description that we have a digital product passport. We know that this will be the way in which everybody and each company has to go. And for this, we know that there must be a solution for it. And E-Class works for this only in the semantic area. We are not a standard for everything. So we work together with other standards, but for the semantic theme, what we have to describe products, to um, uh, 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 bring some functions in it. And I explained that E-Class is very far in the cooperation with the IDTA for the asset administration shell. We know that there are combinations between machines, this kind of asset administration shells, to the buildings, because you have machines in the buildings. You have a lot of complicated things in the buildings. And in the end, there are some similarities between these ideas, AAS and the BIM. So always we want to go to digital twins in the end. And for this, we need this kind of properties to describe everything, to go into the direction of digital twins. And E-Class wants to support the semantic point of view, and we are very far in this area.
Thank you very much, Andre. So we have taken a little bit more time, but it was worth it to hear you go further. Andre, Gerard, Mirbeck, it's been a pleasure to have you illustrate something that is very important for Build Up, that is how important is data to make the right strategies for the building. An absolute pleasure. A big thank you for all of you, because you closed the year 2024 with us, and hope to continue to hearing about E-Class and building smart and Annex 2091 in the future. Please keep on touch because we want to follow you. We will follow you, but we want to hear you again. Thank you to all the three of you. Thank you also to the audience for attending today's webinar. A reminder that you will be able to find the recording of today's session on the Build Up portal and our YouTube channel in the coming days. This is the last webinar of 2024. Build Up has several webinar sessions already in the pipeline for 2025, so keep an eye on the Build Up calendar of events and our social media for updates on this. Be sure to register on the Build Up website to be able to share and disseminate your own content and follow us on social media for updates. All the Build Up team takes the opportunity to wish you a very Merry Christmas. Thank you and goodbye.
Thank you very much.
Thank you. Goodbye.
Thank
very
you.
much.
Likewise. Thank you.